This video will discuss multimedia science's Jectile materials. Jectile is a software game designed to help teach physics students the basics of projectile motion calculations. There are a set of materials that are designed to lead students to be able to do these calculations and then to play the software game. The materials are available from a menu, a software menu. There is a lesson plan which details step by step exactly the objectives, the PowerPoint, which is a brief history of artillery and projectile motion. The idea is to show how projectile motion changed the nature of artillery and the use of artillery. There's worksheets that students can use to practice. And then finally, there is the Jectile game. And this includes discussion of each of the games and the solutions. Okay, let's take a look at the Jectile game itself. Starts off with a warm-up where students have to answer some simple questions, which you may or may not have talked about ahead of time. What is the angle that produces the maximum range in the x direction? That's 45 degrees. The greatest height will be 90 degrees. The greatest time in the air, 90 degrees. And the acceleration is minus 9.8. Check the answers. There's also a testing range, which allows students to, if they're not sure of the answers, they can make a number of shots and be able to figure it out. Unfortunately, I guess I got to go back and do this again. Okay, you can see we've got it all correct, so we can move on to the game itself. So there are 10 missions, and students can choose any of the missions, but in order to go on to a higher problem, they have to solve a simple one first. Pretty simple. Hopefully they're given the height and the range, the x and y values. They have to do the calculations and then hopefully hit the target. Unfortunately, guessing is not a very good way of solving the problem. As you can see. Go back to the mission menu. We'll try that again. Notice that there are question marks here, which when you click on them will describe to the students what their objective is, what each of the items on the screen are, and how to proceed to take their shot. Notice that in every simulation run, the numbers are changed, so they're not the same from mission to mission. Let's take another shot. Okay, that was much more successful. Now we will go. Now, we've talked about, at least in the notes, it talks about how to handle a horizontal shot, but now we've got wind. I find it very interesting. We take students down to a lab and have them run this game, and they're totally befuddled by what they're going to do. And I love to see them working together and trying to decide what the best answer is. So this is certainly a more difficult problem. So in order to get students prepared to play the Jectile game, you saw the lesson plans. There's a worksheet of sample problems. And at the end of the PowerPoint, they're going to be asked to come up with some pre-calculated equations. This is very typically done in the real world, where you don't want to have to go through the whole calculation every time. So if you know that the acceleration is 9.8 meters per second squared, if you know what kind of calculations you have to do, you take the calculations as far as possible and come up with the most simple equation possible to solve your problem so you can do it quickly. And that's what happens in the PowerPoint. Talks about the initial history of artillery. Let me show it to you in a smaller format. Talks about gun laying, elevation angle, the use of a quadrant, how the range in artillery has changed from World War I, World War II, modern days, how from the Civil War, where if you couldn't see the enemy, you had a difficult time firing at them, to now where there's indirect fire, you're shooting such distances that you need spotters. What kind of problems you have when you're trying to actually shoot targets. How they had firing tables during World War II, since most of the artillery people did not know how to do the calculations themselves. And then we wanted to develop some kind of a equation, as we talked about before, that would take the place of the firing table. So how would you calculate the velocity that would be required to hit a target with a given range if you assume the angle is 45 degrees? And we tell the students that they are going to be fighting a battle against aliens. That will be the Jectile game. And when they're all finished, they should end up with this little template to work from for horizontal problem and at an angle problem. And they then will take this into the game, the Jectile game. So if you're interested in getting more information on the Jectile materials from Multimedia Science, please go to Teachers Pay Teachers at this URL. Multimedia Science has many simulations, games, challenges, and experiments. Also teacher tools, game making software. So lots of materials available from Multimedia Science at Teachers Pay Teachers. Thank you.